Hey Kevin, how are you? We'll start in a minute. Nelly, how are you? Last lap today. Okay, so we're gonna do lap 13 today, which is gonna be our last lap. We are going to cover final review next week on Monday, and then you'll have the rest of the time off until final exam. So final exam will be during week 16. That will be just Canvas. You can log in and take the test. Okay. All right. So you can find our lab in Canvas. And on this one, you don't have to use Linux virtual machine, but if you want to use Linux, you can. It doesn't have to be in Linux. You should be able to run it in your IDE like Tawny or in idle. So I want to take this opportunity to cover some of the patterns that we didn't really cover. I know we went in depth with some of the earlier patterns in the creational and some of the other pattern designs. So in this lab, we are going to cover MVC, and then we're going to cover commands, and we're going to cover, let me get my navigation pane, observer. Okay. So for the first part, we are going to do MVC, which is model view controller. And by definition, MVC is the mostly used pattern. We would implement this design and you would see it for interface, especially when you are looking at online shopping or something like that. So on an application, whether it's game or it's a e-commerce app or some kind of app, when you have user interaction, you can implement Python with Django. And ideally, MVC would be used with database or some kind of persistent storage. But we're not going to do persistent storage in this. You can expand it by using SQLite, right? But just for the sake of the lab, we're just going to learn how to use MVC. So in MVC pattern, you would have three components. You are going to have the model, which manages data defining based on rules or behaviors. And it's going to really represent what the application goals would be or the business logic. Your data, which it should be stored in some kind of repository like your database. The second component is going to be your view, and that's going to present the data to the user. So that's what they're going to see. And it would be either presented to the user as HTML page, a chart, a table, simple text output, something like that. It doesn't call in its own method, only controller does that, okay? So the third component is going to be your controller, and this is going to accept the user input, and it's going to delegate data representation to the view. So the controller would delegate how data is presented in view, and it's going to be handled, the data is going to be handled in the model, and we're going to build the components as we go. So we are decoupling model view and controller, and one of each is then be extended, modify, and replace without having to rewrite the others. So what you would see is that we can actually do read update on your data. So in the program, we're going to implement a few things. We're going to implement CRUD, which is going to be create, read, update, and delete. So we're gonna append new data into a list. And ideally, we would use this, right, as a database, but in the program, you would see it as a list. And then we are going to read the existing data. So if it is duplicated, we want to handle the exception. So because we don't want the same data to be stored. Now, if it doesn't exist when the user is looking for that data, then we will also handle the exception, and we can actually implement the body of the exception to notify the user. Okay, you're going to see that it is the exception handling part is still going to need improvement, but you can add in the details in the exception handling. So for exceptions, we want to handle it with abstraction, where we would implement each of the persistent layer as it's looking at the data that's being read, that's being updated or deleted. So when we read, after we read, we can update the existing item or we can remove the existing item. So the program overall is like a list of groceries, for example, and then we would be able to use our Mvc pattern to implement an app that maintain a grocery list. And you can apply this to business application like, you know, online orders, what you see with Instacart and things like that. But in the case of Instacart and online order like Amazon app, you would see that you can add the same items. So in the case that if the user add the same item, we don't handle the exception in that case, we would then just gonna increment the data in the actual container. Okay. Now, if you're using database, all you have to do is to correlate that with the relational table, or, you know, if you're using non-relational database, you just need to make sure that you update the content of the data. So then we want to make a note here that we should ideally use this with persistent storage, where we would implement database table, an XML file, JSON, or even CSV for Microsoft. Now the program doesn't implement persistent storage, and that's something that we can expand on, but it shows you how you can use MVC. Okay. Now we are going to build a package. So you are going to write multiple modules and you are going to import in the modules into the main program and you're going to run it. So for the first step, we are going to write a short little snippet for our exception. And notice here that we're not putting anything, so it's a pass, but you can add in different handling, exception handling methods to be able to, you know, move on from what you would be. Otherwise, as it is now, it's going to stop. So in the case, and we're going to test it where you can see that, right? So instead of pass, you can add in some additional code and it should be able to handle. So these two classes are going to handle the exception. If the items are already in the list, we don't want to add it, right? Like for a grocery list, you don't want to get the same thing twice. Maybe you do, but ideally we want to get only, you know, one of the things that we need. And if the items are not there and we're looking for that, we also want to raise an exception. So those are, so you would write that and it's going to look like this. Okay. So let me clear this. And it's simply 4 lines. Then we are going to go ahead and file, save as, and we want to call it MVC exceptions exactly as typed because we're going to import it into the other module. Okay, so that's one part. So that's going to take care of the exception. Then we are going to have another module, and in this one, what we're going to be doing is we are going to declare some of the methods on how it's going to create, right, read, delete, and all of those things. So all the actions are going to happen on the back end. Okay. So let's take a look at this. You are going to import in the exception handling module, which is MVC exceptions. And then we are going to have a container to store our list of items that will be here. And then we are going to define first, we are going to create item. So it has to be able to generate some kind of data. So with that, we're going to make sure that this is a global list, right? So we use the global keyword. And so for each of these, it's going to access the list. So the first part is we are going to create and list the items with name. If it's already there, we are going to raise the exception and we want to say it's already stored. And that's why we have import in the exception in the first place. Otherwise, it's going to add that to the list or append it. It's going to add name, price, and quantity. And the best for Python would be using dictionary with that. So that way you would have your key and your values. Okay. Then for the second part, we are going to have a second method here that's going to be create items. And again, we're going to use the list items and we're going to reassign items as app items. Now, once we have the data, we want to read the data, right? So because if you add something to your list, you want to see what that is. So the next part, we're going to read. And here we're going to view or see what's inside our list. And for the condition, what we want to just make sure that we're going to start with, right? The first element, return the first element if your items, okay, are in the list. Otherwise, if it's not on your list, you want to handle the exception that it can't read the data if it's not there. And then we would have a second method, read items. And here we want to use a for loop to iterate through everything on our items list. Now we want to update. And so with this, we are going to update. So if there's price change or name change or quantity change, we would be able to use this to update our list. So let's say that if an item is now the price is higher, right? We can update our list to a higher price. So it's going to use the index to be able to update each of the element in the dictionary. And since it is multi-level, right? Name, price, because there's key and value, we want to have the index specified. Okay. And then if it's not there, then we want to also handle the exception, items not stored, from the other module. We can also remove the item by using the delete method. And similar to what you've seen with the update, on this one, we're going to delete. Okay. So it's still going to enumerate through that, but we are going to delete. And we're going to use the delete method here. Otherwise, we are going to raise the exception again. Then in the main, we're going to define our my items list. So we would have bread, price, quantity, and so on. Now, a full-blown app would have some kind of interface where the user can actually enter these or scan it, right? But this is a static list. So we hard code that in. So we would have bread and the price for that and the quantity and so on. Now here's where we call the method. Okay. And we want to add beer to the list. And then we want to be able to print it. So we're going to print the items that are on our list, right? Then after we read, so it's going to print bread. Okay. Then we're going to update the bread with the price. So it went from 50 cents to $2. Now notice that there are comments there. So later on, if you wanted to test like the exception, you can uncomment some of the additional lines like this. Okay, like that. Okay. Okay. So after we have updated it, we would then also have a delete. So we're going to call on delete item. So we're going to remove beer. Then we're going to have it printed. And then lastly, we call main. Okay, so that's the second module. And simply the second module is your main program, where the first one is to handle exception. Now, for the package, the third module is where we would have the MVC. And you can approach it this way, where you would have a main program, right? And then you can have different modules to do different things. And we've learned this in 30A. So after you have the second program, then you would write the third. And this is going to be your MVC. So on this one, we have to import in our main program, which is basic backend. And also the MVC exception because they work together. Then we instantiate item type and create items. Remember earlier we have app items that's different than your regular items, right? So here we're going to use app items. So your item type is going to be listed as product, or that's going to be the string. We have a decorator for property. And so here's where we would define the function. So we would list the type of product that would be. And for the MVC, we would need to also have a set. And that simply would create the data. Now, next, that's going to be all the creation of your data. So since we're using it from the back end, and that's the method we wrote in the main program, we're going to bring that in, and it's going to list the name, the price, and the quantity. Okay. Then we also have the read. And so that would be your to view the items that's appended. Then lastly, we would have a function or a method for update and delete. So we would update the name, the price, or the quantity, and we also can remove an item by name. Now, so you have in an MVC, you would have a class that's going to handle the model, right? The model, recall that we talked about, the model is going to be your main objective. Okay. Then your view, okay, coming back to here. So your model is going to be the data that you are storing. The view is going to be with the user, how it's going to show to the user, what the user see. And then the controller is going to be the input and the data delegation. So this is where we would have the user now before the input, right? How it's going to present the data to the user. So in this section, usually you would only handle like display or show, right? Hence the method that's defined there. And you would use static method. So you want the data to be presented in a certain way, right? Like how it would be listed or shown. So it's going to print everything in uppercase. Then we also want to have numbered lists. Then next is going to be, we're going to show some of the update, right? As we are looking at what's in it, what's updated, and what's being deleted, right? So here we are going to show the items, and we're also again going to format it. So as you can see there. And then if you have missing item, we wanted to have something to be able to display that. And also something that we already have on the list. So those are the things that we originally handle as exception, but we want them to get a message, right? Saying that certain things is there and certain things is not there. And as the item is stored on the list, we want to also say that, how you add things to cart, it always pop up that message saying, oh, you have added an item to the cart. Click OK here to view your cart or, continue shopping, right? So that's the same perspective. The view that you see from the user when you're using the app at that point is what we see in the view class here, right? So every action that the user would take, right, you want to present some kind of information for that action, and that's this section. And if price is updated, or let's say that I bought something that's no longer in stock, right? All of a sudden it changes, then it should notify me and it should update that the one is going to become the 0. So it should remove it from my shopping cart or prompt the user to do that, right? So in the view, it should display the data and how, for each of the process that the application is going to go through, or how the user is going to interact with the application. Okay, so we have updated, deletion, change, how it's stored, we added it, if it's not stored, and so on. So that is mainly the view section. Then you have the third component, which is the controller. This is where you would have the user input and data delegation. So we instantiated model and view, as those two are the major components for MVC, hence the name, right? So the first two objects. Then we're going to read the items So that's going to allow us to display. And so now for the show items here, okay, it's going to simply show what's being added. In the next part, that's going to handle the exception as well. Okay, so the three areas that we want to address is we write a module for exception, but we want to incorporate that in our MVC, which is here is where you would implement it in the controller, because the view is just the message to the user. Now, for the next method, this is going to allow us to add the item or insert the item, and that's going to we're going to do an assert here and try. And a lot of this, you would see that we would use exception handling techniques, because in the case that if it doesn't work, we want to be able to proceed. Otherwise, it's going to get stuck, right? The app is going to halt. Okay. So the price, we wanted to check and make sure that it is greater than 0. The number needs to be greater than 0. And so that way it would have appropriate update, which is the next step. So as they enter the type of item or the quantity of item, you want to be able to handle that. Okay. Then after that, we're going to update. And so we have to compare our original data to what would be introduced as new data. So that would then be this try section. Okay. And then you want to be able to handle the old and the new data there. Then lastly, you have a deletion method, and this is going to be to remove the item. If it exists. If it doesn't, we're going to handle that here. So this is going to be the MVC, the pattern portion of the program, right? So when after you save the 3 files, you're going to run the main file, which is the basic backend. Okay. So here you would see how it read. Okay. Like bread, milk, wine, and beer. And then, so we are going to read the individual item. It's kind of like you looking at a list, and then you're going to narrow down to an individual product. So here we're going to look at bread. Then we're going to update the price for bread. Okay. We're going to get rid of beer. And then we would have a final list with the new price and the beer removed. Now this would be much better, like I said, with database, but you can also use JSON and other things, right? But you can see that it can be done to test in Python. So after we run the program, sorry, it's a little lengthy with all the code added. Let me go to the next section. Okay, save your modules. I had a typo here. And then run the basic backend file. And make sure that all your modules are in the same location, of course, right? Because it's the package. It's going to need all of the files to work together. Take a screenshot. Explain how MVC pattern is implemented in the program. You can look at the actual file itself, and then you can talk a little bit about, you know, what is in the model, what is in the view, and what is in the controller. And if you need to apply this to your own project or future application, how would you use MVC pattern? There are a lot of different examples that you will find for MVC, right? Especially with web, with Django. So if you plan to do like UI, UX, you want to be able to explore how this can be done with Python and the framework. So tell me about how you would use MVC pattern in an application. We looked at the example and we say that we can use it for, like, you know, an e-commerce app. If you can think of another app, I think it can totally work with games, because if you think about it, pattern is very useful for game development, right? Like even the game where you have in-app buy, where you can buy, you know, additional, I don't know, lives or tokens or whatever it is. So you can definitely have that update component to it, and then be able to implement and then the change, the modification for that particular user profile. And then if you take it into IoT, IoT is definitely useful, because you think about it, right? The status for the IoT, we can use that as an update in how it would change, like smart lights, smart devices. I've looked at some pattern example. It's really interesting how they implemented that with, you know, like smart devices and how that updates the web or it tweets or whatnot. Okay, so answer those questions or complete those 3 things after we run the program. Really easy. Any question on MVC? And instead of going through chapters, right, like what we normally would with the assignment, I added command and observer on here in the case that you want to use it. And of course, that you would see some example in the textbook if you have it. So these are a little bit more complex than what you've seen with model view and controller. But command is, you know, it works really well when you're looking for, you know, you building a certain app that's going to execute something that's event driven, like clicking a button. Okay, so let's talk about part 2, which is on command design pattern. This is a behavior design pattern. And this is, you would use this when you have an object that needs to invoke a command, and then it would invoke and execute it. So this allows you to use the pattern as an abstraction between the action and the object that invokes that action. And that could be automated. It doesn't have to be user control, right? So in the design pattern, you would know that the client, right? And we'll define the client would create a command object using a list of command to be executed. Okay. So the example here would be that you would have a button that will be the invoker. And we can say that it would use a specific register command. And sometimes some command would be OS oriented, right? And once the receiver gets it received the information, it's going to perform, it's going to execute whatever that command would require it to do. We're going to see a concrete class, which is going to be a delegation of your command object. So it's like the manager. Now, the command design would allow you to solve the problem independently. Okay, so you would be able to do something like logging the execution. So an example of this is if you do like undo and redo, right? Like if you think about on the OS side, right? If you do Control X, that will be undo, right? So a strike of those combo keys or the functional keys, that's going to be giving you some kind of execution for that command. And we can do the same thing in a program. Let's say that we would create a GUI button and we would say to click it for the redo and click it for the undo. So as it is event driven, the user will click that. It has to execute something, right? Simply just a function. This can be used in networking, parallel processing, threadings, transactions, like if you want to process transactions, if you're creating a wizard, right? Windows have tons and tons of wizards to walk the user through, different things. It's like installing server roles and then so on. So there's some example on how command design pattern would be implemented. So here we need to define some of the components for command design pattern. The receiver is an object that receive and execute the command. The invoker is the one that sends a command to the receiver, like a button. The command object is implemented to execute or take action, which contains all the functions that would be required to execute it. Then your client is going to be listening. So that would be the application or the component that would be aware of or listen to the receiver, the invoker, and the commands. So the way it looks is like this. So the invoker sends the command type. Okay. And based on the list of command, the receiver would be able to recognize the type. And then it would then execute the command. Okay, any question? So the pseudocode for this, so this is basically what we're going to achieve, right? Instantiation of the receiver, which accepts a certain command and it needs to execute it. The client is going to make two command objects, and the client is going to create an invoker. That's going to be the interface with the buttons. Then the call is going to register to the command object. So then when we execute it, it would then take action. Okay. So this would allow you to add in functionality like, you know, history, replay, undo, alerting, and so on. So you see this is commonly used in apps, right? All application has some kind of functionality like this. Okay. So let me clear. Let's take this down. So we are going to use ABC as what you've seen in the other example on Monday when we talked about the other patterns. And from ABC, we're going to use abstract method and ABC meta. Now we are going to first design this class. And this is going to be, so in the parameter here, you have to put the meta class is your ABC meta. Okay. This is going to be how you're going to implement your command interface. And it's going to hold the execute function. So you have to define execute. And notice before we need to decorate static method and abstract method. Now, then we would have the invoker, which is the other component. We're going to instantiate the commands. That would be a dictionary. Okay, so as it needs to send the command to the client or the receiver, it's then gonna, we have to register. So that register the commands in the invoker. That's one of the process. And second, we have to execute any registered command. Okay. As it does that, we want a confirmation. So it's going to be I borrowed this code from a website that actually, well, Sean Bradley is the one that does a lot of the tutorial in this area. If you've seen him on YouTube, you can subscribe to his channel. He does a lot of like advanced Python. And as you notice, right, he's Australian. So that's why you see the typing is like this. Okay. Then the next component is your receiver. And your receiver, remember we talked about how it would be two command 1 and command 2. And in that we would also decorate static method. Okay. Then we have the, now we're going to break down to the each of the command. So in this part, that will be your command 1 on how it's going to run the command. And here we would instantiate the receiver. And remember, the receiver is going to be the one that runs the command. right? Because the invoker is the boss. The receiver is the employee, right? It has to execute that. Command 2, same thing, right? Pretty much. Now we want to create a receiver object that would be for the receiver class. And then the command object, command 1 and command 2. Invoker object. And then here is where we would register command 1 and command 2. And then we would execute 1, 2, 1, 2, and so on. So when you execute, you notice that you would have the invoker here. Okay. So we would go ahead and run. And of course, you're only going to see text output because that's what we told it to do. So it should give you executing command 1, executing command 2, executing command 1, and executing command 2, because that's the order for the execution here. Okay. Now tying this to some kind of button, right? I know when we did 30A, we talked about how it would invoke some kind of action, and then we would define a method on what it's supposed to do. Okay, like you can have it, write to file. So if you write a program to generate some kind of logging for the user, like I'm gonna go back to my example for like the keylogger, right? So let's say that you have a pop-up window with a button say, click here to win $1 million. And then when they click it, it should activate something where it would be that it's going to read every user input and put it into a text file or send it somewhere, right? So with that, you can specify the type of command that you want using command pattern. Okay. Okay, so the code is provided there, a little lengthy, right? We looked at that. So at the end, same thing, take a screen capture, explain how the invoker is implemented in the program to execute the command. And you see that on the bottom here, but just go to the section where the class where we actually define some of the method or the functionality of the invoker. Sorry. You should say, how would you use command design pattern in an application? What would you do with a command pattern? So tell me how you would use that in an application. Question. So think about your project and how you would use it. So what's the purpose of registering a command? Okay, go back to that. So if you look at if you look at the UML diagram, if you don't register the command, right, it would not be able to see what kind of command. So that's like a confirmation of what type of command that you would tell the receiver to execute. Okay. So with that, it's a way to clarify what would that command be. So here, right, you would say that the command would be this type of command. And you can have a command to do this, to delete, to undo, to copy. And so that will be more on the specific what that the action of the command would be. Because the execute is only going to carry out that action. Okay. Now in the invoker, we instantiate what the dictionary, which is the command, which has command name and command, right? But with that, you have to specify, right, what type of command that would be. So if I press a button or strike a key, it's going to execute the specific. So I think for the registration part, that would really narrow down to the type of low level input and output for the machine. So we can say that when it executes, so if you do copy, that could be named copy, or it could be registered as C or A or B. So it's just a way that we would also identify that, but at the low level it would execute it because your function already tells it what to do here, right? What kind of what the receiver, what it's doing here and what it's supposed to do here. So when you define the class command 1 and command 2, that's the action of the command. But this is going to be AKA, right? What it's known to the invoker as. So the invoker is, think of it like a manager of that, the process. So what it would see it as, the first command is going to be named as 1, right? That's going to be identified as 1, and that will be command 1, command 2. So you can say that if this is, it would be registered as copy, then it would do the copy, or it's registered as deep copy, then it would do deep copy. So it's just a way that invoker sees the command. And then on the subclass, it would then be able to execute the method to perform a certain action. Yeah, because you have various components, so the invoker has to see that as something because it doesn't execute it. So you have to identify those commands to the invoker, because the execution is done in the receiver, right? So it would order the receiver what to do. So in order to order that, it has to say command 1 or 1, right? Copy, delete, undo, and so on. And that's going to be what the receiver is going to execute. Okay. Other questions? That one's pretty fun to do. All right. Last one is on observer. So observer, if you look at some examples that are available, a lot of people, they present observer pattern with MVC. Okay. Because it's close to it, or closely related, at least. So this is a pattern, excuse me, in which the subject, which is the observable, manages a list of dependents, which are the observers, and notifies them of automatically of any internal state of changes by calling one of their methods. Okay. And the way that it's designed, it's put together is that there is a subscriber, a publisher, and an observer. I think we talked about observables before earlier on, right? So the subscriber is subscribing to the publisher. The publisher notifies the subscriber when it's necessary. The observer would then store the state that would be consistent with the subject. So the observer only store what's necessary for its own purpose. So kind of like similar to what we just talked about with the command design, right? But in this, the subscriber would be subscribing to the publisher. So the publisher would notify, would message it or would update it of what needs to be changed. And then observer is where the state or the change would happen. So you would have an interface, concrete subject, observer interface, and concrete observer. Okay. Now, this is a little lengthy. Okay. So when you use this is going to be between the application and the presentation layers. So for those of you who are familiar with networking, you would know, right? So that's before data would be shown to you once the data is received, right? So when it's at the presentation layer, it would then preparing for the reassemble of data and then before it presents that, right? So it needs to do the decoding and then the encoding process there and so on, depending on, you know, the type of data, the protocol, and so on. So your application manager of the data would then be your source of data. And it would need to update all the subscriber that will be part of the presentation. Okay. So if you're looking at, let's say that the example is that a sport game and all the web browser clients, the mobile phone applications, and the leaderboard display would be shown on television. How can you synchronize this? Okay. So we have to find a way to notify all of those in order to update. And the closest thing that we would see this frequently is how you synchronize your devices if you're having smart devices like your smartphone with your laptop, with, you know, your TV, with, you know, all your smart devices at home, right? So when you change something on one, it needs to really notify the rest to update. Okay. And that's pretty much the example that's shown here. And here it says that you would use the separation of data in the presentation that would be broken down to your model view controller concept, where you have controller, model, and view, like what we talked about earlier. This is a way that we would manage how you would transfer data across the layer internally. Because if you're looking at network wise, right, data is going to arrive in non-order form, right? It's disassembled. So in order to really organize it and present it to the application, we would need to make sure that we have a way, a centralized area where we would update that, right? So if you're looking at devices across the network, right, might have 1,000 of devices, we would have to have a way that we would centralize it and be able to disperse that information. And so that's the same abstraction type of model that we're working with. Okay. So this allows you to use or reuse the observer and then add the observer as you modify the subject for the observer. So you might have one, think of like if you have one device, not necessarily managing, but when you update that device, it would then update all the other devices, right? So the other devices are subscribing to it as it would also subscribe to the other device. And the other devices are observing, so it's always watching and looking at what has been changed or the state of the change. Okay. So here it talks about how you can push updates using this kind of thing. So think about like update applications, databases, synchronization, replication for network. You know, you see this with network operating systems where we would then have to synchronize with all the child servers or, you know, the other domain controllers and so on, and update, right, policies, objects, users, groups, and so on. Okay. So it would be useful in that sense, an application that would require that kind of mechanism. Okay, so it talks about the push mechanism. And this is the UML diagram pattern. So you have a client applications. You would have the observer. And so the subject is gonna then need to be created. You would also need to create observer that's gonna listen for the notification from the subject. So just like what we talked about with some, you know, you have a component that controls, right? You see that in these patterns that you're going to have something that's centralized here. So the subject is going to tell the observer, it's going to notify the observer the state. Now, if one of the observer is, it's going to unsubscribe from the subject, then it's gonna then not be able to do the update. So the subject would notify the rest of the other observers, okay, that a change has been made when one of them is unsubscribed. And you want that in the network because in the case where you have, you know, this misconfiguration, you know, disconnection from the network where you have interrupted line, power down, etc., and you can't push, right, the updates or the changes, then you would have to notify all the other systems. And so that's basically the concept that's implemented here. Okay. All right, so let's take a look at this program. Okay. So you are going to use ABC module when you use either observable or command. And we have to create your subject interface. Okay. So here, this class is going to be your meta class. That's your ABC meta. You always want to start out with that, just like the other one. And then you would have your static and your abstract method. Then after that, we would define the function for our subscribe and unsubscribe. And that would be the argument here would use observer. We also need to notify because those are the three tasks, right? It's going to subscribe, unsubscribe, or notify. Then we are going to next, we are going to design, we're going to implement the subject class, which is a subclass of IO or iObservable. Instantiate observers. And here is where we would have subscribe. Those observers going to subscribe and then unsubscribe and notify. Here is the observable. Next, we're going to have the observer. And that's also going to be a meta class. And again, we would do the same thing. We would have it notify. So for the observer, it's going to receive the notification, right, from the subject. So in the observer class, which is part of this, okay, it's a subclass of iObserver. Then we're going to instantiate, and this is only going to be notify. So when you look at this, the way it's structured is the observable, right? It's going to have these three functionalities: subscribe, unsubscribe, and notify. And that would be for the subject. And in that class, that subclass, you would then also need to define those three tasks. Subsequently, we have the observer. Here, this is the meta class, and so the subclass of that will be the observer, and it's only going to use, we are going to only define notify. Then for the client, right, you have a subject object. We would have observer. Remember that in this program, we're doing two observers. So you have observer A and observer B. And you are going to have, it's going to notify, and simply we're just going to have 1, 2, and 3. So first notification, it's going to show 1, 2, and 3. Then we're going to unsubscribe the second observer, which is observer B. Then it has to notify the rest. Okay. So the first notification, it shows the ID there and it's received. Let me scroll down so you can see. Then we're going to unsubscribe B. And then we want to, it's going to notify. So why is it sending me two notification here? Is because we originally have two observer, right? A and B. And then when we unsubscribe B, okay, we have it send the second notification. Question. Okay. So after we run the program, take a screenshot, describe how observer design pattern is implemented in the program. How would you use observer pattern in an application? Right, think of an application where you would implement observer design pattern. Okay. Any question? I see a chat question. Yes, there are a lot of protocols that use this type of mechanism, push, right? So it's a push state mechanism. That means that it does the update. We have, like, I know that from like the DNS side, you do have that with dynamic updates. Okay. There are a lot of different type of things that we use in networking that really ties to this. Routing also ties to it because, depending on some protocol, but there are protocols that it would update. So when a route goes stale, it updates itself and it notifies the other appliances, right? And so because the other appliances use its routing table and the neighbor's routing table to be able to determine fastest route. So and then when you think about databases also does that. Okay. When you modify records on one database servers, right, you want that to be updated to the rest. So it needs to modify, and then when one drop off, it should also be notified again. Questions? Okay, so only the steps are pretty few. Okay, you only have like 3 for each one. And so it's due on Sunday. If you have it finished today, you can turn it in today. Again, I just want to remind you that, we will have a final review session on Monday. We'll go over the concepts that we have covered in this class for final exam purposes. I will give you time to work on your project. So that would be, if you finish everything else at this point, then you just need to work on your project and then prepare for the final and you're all set. If you have any kind of outstanding or late assignment, I know I need to catch up grading on this class. I will try to do that tonight and tomorrow. Then you can turn that in by the 5th of December, which gives you a few weeks. But if it's locked, email me, let me know, or Canvas message me. All right, I'm going to stop recording.